Good afternoon to all. Let us join all, then we'll start. We'll wait for 2-3 minutes, then we'll start.
Good afternoon, sir.
Good afternoon.
Okay, sir.
Tell your friends to join quickly.
Okay, let us start. Let me share the screen. Is my screen visible?
Yes, sir.
So yesterday we have discussed a very simple circuit of diode. Then we have found out the maximum voltage, maximum current, what is load line, then what is Q point. Okay. After that, we have discussed for common emitter configuration. There also we have found out the voltage, maximum current. After that, we have plotted the load line and the transistor characteristic. And what we have observed, we should operate the transistor in the active region so that proper amplification or faithful amplification we should get. Okay. So for choosing this IB 30 microampere for this example, or at the center of load line, we have to choose the voltage and resistance. So for proper choosing of voltage and resistance to operate the transistor in active region is called as biasing. Okay, so if you go to the definition, see here, as shown in the figure, the optimum point is located at the middle of the load line in order to get faithful amplification, and the Q point must be within the active region of the transistor. And transistor biasing means proper choosing of voltage and resistance so that the transistor will operate at the active region. Okay. Once you fix that one, still there is some problem. Let us discuss that one. Okay. So what happens, if you remember in the diode chapter, I have told you the leakage current is depend upon temperature, as well as the junction voltage also depend upon the temperature. So these two things we'll discuss here. So what is written here? This point, even though the Q point is fixed, it is very important to ensure the operating point remains stable once we start the operation. Okay. So if the Q point shift, then the output will be distorted. So in practical cases, 3 parameters are affecting the Q point once I'll start the operation. So what we'll see, suppose this is my load line and these are the characteristic. Okay, and this Q point I have fixed. This Q point is fixed. This is IB, let us take 30 microampere. This is IC, this is VCE or VEC. Now once I start operating my transistor, then what are the problems arise? Let us see. We know what is the equation of IC. IC equals to beta IB plus ICEO, or beta plus 1 ICBO. I can also write like beta IB plus beta plus 1 ICBO. Already we have discussed this thing. Now suppose temperature increases. Temperature increases means leakage current will increase. Leakage current will increase means that will increase the IC. So IC is increasing means whatever IC I have taken here, this point will shift upward. This will shift upward means I may get this Q point, or my transistor may operate at this Q point above that. Okay. So if you observe the last class graph, this one, I have chosen Q point as this one. If my Q point is shifted upward, maybe here or here, then this positive portion may clip. Before starting of operation, I have fixed my Q point here for IB 30 microampere, but due to increase in temperature, ICEO will increase or leakage current increase. That leakage current is added to the collector current, and collector current is increases means my operating point will shift upward. If it is shifting upward, then maybe the upper side of the input signal, or which is amplified, that may be clipped. So this is a problem when temperature increases. Similarly, if you remember, in the diode concept, I have told you for every 1 degree rise in temperature, the junction voltage decreases by 2.5 millivolt. Okay, so this junction voltage means diode junction voltage. Now, if I consider same thing as transistor circuit, let us see the transistor circuit I have drawn. This one. So this is P, this is N. So this is like a PN junction diode. Now for every 1 degree rise in temperature, 2.5 millivolt junction voltage. Can you tell me what is the junction voltage here? This is my base, this is my emitter. So what is the junction voltage? This is the base terminal and this is the emitter terminal. So what is the junction voltage, or what is the voltage between these two terminals?
VEB.
VEB. So VEB is decreases by 2.5 millivolt. Now VEB is forward bias or reverse bias? Emitter base junction is forward bias or reverse biased? Look at the figure and tell me. N is connected to negative, P is connected to forward biased. Now this junction voltage decreases by minus 2.5 millivolt means it is less forward biased. Okay, so whenever temperature increases, the junction voltage drop, means it is less forward biased. So when we are taking the junction current, when I am increasing the voltage, current is increases. Now if I go opposite way, less forward bias, then current will increase or decrease? Look at here, current and voltage. So when I am increasing voltage, current is increases exponentially for forward bias junction. That means I am moving from lower to higher voltage. Now if I go from higher to lower voltage or decrease the forward bias voltage, then current will increase or decrease?
Decrease.
Decrease. That means this IB current will decrease. Once IB current decreases, let us see the circuit, the characteristic here. IB current, I have set 30 microampere. Now it will decrease to, let us assume 20 microampere. Then my Q point will shift here. Initially I have fixed this Q point, but ultimately I am getting Q point here. Or maybe it will decrease here also, this Q point also. So ultimately what happens? If I set the Q point here, then lower side may be clipped. Okay, there is a possibility. So two possibilities we have seen. One is due to increase in leakage current, my Q point is shifting upward. Due to increase in temperature, my Q point is shifting downward. Okay. Now beta. Beta is another parameter which is affecting my current. You see in this equation, IC equals to beta IB plus beta plus 1 ICBO. Beta is a factor, and this beta is very much dependent on temperature. Slight increase or decrease in temperature, beta will change. Okay, so three things we have seen. One is leakage current, one is base emitter junction voltage, and beta. These three parameters will change if temperature will change. So no doubt I have fixed my Q point here at the center, but if temperature changes, that will may change my Q point up or down. And this is the temperature, or the main culprit is temperature, and I cannot control the temperature, because wherever we design any circuit or if you purchase any electronics equipment, there's some standard things will be written there. Rating, it should operate at room temperature, maximum current, maximum power, maximum voltage, everything will be written. If you change that condition, then it will not give you optimum result. Okay, so that's why, because suppose I am using the amplifier circuit and it will be written there room temperature. This temperature may vary in summer and winter, or place to place it may vary, or condition to condition it will vary. So I cannot constrain the temperature. So temperature changes means all these parameters will change. Okay, so we have to think such that even if the temperature changes, that will not affect my Q point. Wherever I have fixed my Q point, that is at center, that should be fixed. So biasing is nothing but proper choosing of voltage and resistance so that my transistor will operate in active region, as well as fixing this Q point at center of the load line. Okay, so let me write the definition so that you will note down. Proper choosing of voltage and resistance so that transistor will operate in active region as well as Q point is at center of load line to give faithful amplification. Okay, this is biasing or transistor biasing. Okay, understood? What is transistor biasing? Proper choosing of voltage and resistance so that my transistor will operate at active region, as well as Q point will be at center of load line so that I'll get faithful amplification. So look at here, I have to choose this voltage resistance such that Q point will be at center as well as in active region. This yes
sir, एक बार वो
definition write down.
Thank you, sir.
Now you have understood what is biasing. So the problem what we have seen, IC equals to beta IB B. What I told, leakage current will increase. Leakage current will increase means will increase the transistor, that will increase the heat across the transistor. So that heat resulting more increase in temperature. So this is like a cumulative process. It's like a chain reaction. So if that starts, then after some time, a condition or a time will come where huge amount of current and heat will develop across the transistor and transistor may burn. That condition is called as thermal runaway. Understood? What is thermal runaway? If temperature increases in a transistor, then it will increase the leakage current. Then leakage current will increase the collector current. More collector current will develop more heat across the transistor. That will again increase the temperature. That temperature again increase the leakage current. So this process is like a chain reaction or cumulative process. And after some time, the current will huge and this process thermal runaway. And this is also unavoidable because temperature increases means happen. As a D, what we should do so that this chain will break. if I break this chain, then even if increasing temperature, or if I break the chain here, even if temperature increases, the increase in leakage current will not affect my IC. So that thing you have to think. There are certain circuits are there, like you have studied, which will capture more current without changing the voltage or without damage the diode. Thermistor is another one which will be used. So what is the logic here? The circuits are not given in the course, only logic I'll tell here. So how much current is increases due to increase in temperature, that same amount of current bypass to some other circuit. Suppose due to increase in temperature, 2 milliampere, or let us take 20 microampere current is increasing here. I have to bypass this 20 microampere to some other circuit that will not added in the collector. Then this chain will break and will not get detect the transition not happen. Okay. So that is one possibility. There are different circuits available which is using this condition. Okay, understood? So definition, if you want, here is the definition. IC equals to beta I plus beta plus 1 ICBO. As temperature increases, leakage current, increasing collector current, power dissipation. The increased heat again increase the temperature. Spelling mistake here. The whole process is repeat, and it is a cumulative process which may damage the transistor. This is called thermal runaway. Okay. Now we have understood three parameters like ICO, VBE, and beta, which are affecting my collector current, and these are due to increase in temperature or change in temperature. Okay. Now if I want to find individually how IC is affecting my ICO is affecting my IC, VB is affecting my IC, beta is affecting my IC, then we need to find out the stability factor. Okay, so stability factor is a parameter which will give you the how much increase or decrease in ICO, or what is the effect of leakage current on IC, what is the effect of base emitter voltage to IC, what is the effect of beta on IC. So there are three parameters: S, S dash, S double dash. S means change in IC to change in ICO. That means how much change in IC will seen if I'll change the leakage current, or if the factor is like 5, then one factor increase in leakage current will affect 5 times in the collector current. You can think like that. Okay, that is the way you can understand. Similarly, if I want to find out what is the effect of base emitter voltage on IC, then del IC by del VBE. Similarly, S dash means del IC by del beta. So you can see here all are partial derivative, because at a time 3 parameter effect I cannot take. So once I take the one parameter, other two are constant. So for S, beta and VBE are constant. For VBE, ICO and beta are constant. For beta, ICO and VBE constant. Okay, so like you have studied partial derivative in mathematics, so any equation you can take and do the partial derivative. Once I go for fixed bias circuit, then also we'll find this stability factor here. Okay, understood this one? So that thing is mentioned here. Okay, so the rate of change of IC with respect to ICO, keeping VB and beta constant, is denoted by S, this one, and similarly S dash and S double dash. So we have understood what is load line, what is Q point with simple diode circuit, then transistor common emitter configuration we have taken. Again, we have seen what is load line, Q point, and what is biasing. And once I fix the Q point, what is the effect which are affecting my Q point to shift upward or downward, and how to avoid that, and what is the logic, how to avoid that. And in between, we have discussed what is thermal runway, as well as the effect of these parameters on IC, how to find out how much effect is putting on this IC by this leakage current, base emitter junction voltage, and beta. Okay, now we'll see the biasing circuit. So in your syllabus, only one biasing circuit is included, which is called as fixed bias circuit. Okay. So very simple circuit. Already have gone through this circuit while solving the problem before mid-sem. I have given one question. In fact, two questions I have solved here. So I will take 10 pin, so that will be current will be same. Okay, so that this is your emitter, this is your IE, this is your IB, this is your IC, and here to here base emitter voltage, and here to here VC. So this type of circuit is called as fixed bias circuit. Why it is called as fixed bias? Because once I fix the VCC, and RB, the IB is fixed. Okay, IB is fixed. So that's why it is called as fixed bias circuit. Generally, the circuit will be given, and you have to find the parameters VCE, IC, IB, VC, and VE. So 5 parameters you need to find, and this will be a 5-mark question. Or even sometimes the circuit will be not given, only parameter means VCC, RB, RC, all these what type of transistor will be given, and there will be given that the fixed bias circuit, using these values you find output voltage VC, IC output current, input current IB, and the voltage across collector terminal and voltage across emitter terminal. Okay, so 5 mark. First you have to draw the circuit, because the circuit is not given in this question. Then you have to find all these parameters. So how to solve? Okay, very simple. I need to find out VCE. Okay, so VCE means the voltage between collector and emitter, which is equals to the supply voltage minus drop across the RC. Yes or no? Otherwise you can go for KVL. So if you apply KVL, at output loop, what will get? VCC minus ICRC minus, this is plus, this is minus, VCE equals to 0. So VCE equals to VCC minus ICRC. But I don't know what is IC. It is not given in the question. So I need to find out IC. How I'll find IC? IC equals to beta IB. Even beta is IB, beta will be given in the question. Otherwise you put beta as it is. Then we need to find out IB. So IB equals to, apply KVL in this loop. How to find out IB? Apply KVL in the input loop. So VCC minus IBRB minus VBE. Right. So here I am starting VCC minus this current IBRB minus base emitter voltage is equals to 0. Then you can find IB equals to what? VCC minus VBE by RB. This is your base current. So I have done from output to input, but actually you have to, because nothing is given, so first you have to find out IB, then you have to find IC, then you have to find VCE. Understood? Once you find IB, then only you can find IC, then you can find VCE. Is it clear? Then what parameter we will find? Okay, this voltage is your collector voltage, and this voltage is your emitter voltage. What is VE? Can anybody tell me? What is the potential at emitter terminal? This emitter terminal is grounded. So what is the potential at emitter terminal?
Zero.
Zero. So VE equals to 0. Now VCE, we know VC minus VE. So VE is 0 means VCE equals to VC. So I have found out 1, 2, 3. Then this is 4. This is 5. So 5. My question 5 points. Okay. So I'll give one question. Solve this way. Same circuit, only I am giving the values. Or I'll again draw the circuit. That will be easy. VCC 12 volt, RC 2.2 kilo ohm, RB 240 kilo ohm, then C2 10 microfarad, and here C1 10 microfarad. Here AC input I am giving from here. Then you need to find out VCE, beta equal to 75, silicon transistor. Find VCE, IC, IB, VC, VE. See, this capacitor C1 and C2 is connected here. So you don't bother about that, because this capacitor actually called as blocking capacitor. Whenever we are giving AC from this side, whatever DC is present in that AC, that will block by this capacitor. Similarly, this capacitor will block the DC. At the output we require AC. So DC and AC both are amplified by the amplifier. So DC will be suppressed there and AC will get at the output. So that is nothing with this circuit calculation. So forget about, even if the question is given like this, then you forget about C1, C2 and solve as I have done. Quickly do it and tell me what is IB, what is IC, what is VCE, what is VC, what is VE. What is IB? Anyone? Formula is written here. If you want, then I'll just scroll it down. See? Quick. जल्दी करो, आंसर क्या है? First, what you will find? तुम लोगों को सुनाई दे रहा है कि नहीं दे रहा है?
यस सर।
बोलो, क्या पहले क्या निकालोगे? IB ना IC ना VC? इक्वेशन लिख दिया, सर्किट लिख दिया, वैल्यू दे दिया, वैल्यू पुट करके निकल नहीं पाओगे? इतना लेट हो रहा है तुम्हारा।
सर IB 47.08 माइक्रोएम्पियर।
मुझे तो पता नहीं, यहाँ पे निकालना पड़ेगा। So how will do? Apply KVL. So from here to here, so VCC minus IBRB minus VBE equals to 0. So IB equals to 12 minus 0.7 divided by 240K. कितना हो रहा है? चेक करो। 11.3 divided by 240 मिली एम्पियर। किलो को मैं ऊपर ले लिया तो मिली हो जाएगा। तो 11.3 by 240 कितना हो रहा है?
0.047।
0.047 तो माइक्रो कर दो, 47 माइक्रो एम्पियर। IB should be expressed in micro ampere. Then IC equals to beta IB. So beta is given 75 into 47 microampere. So what is IC? 75 multiply करो
3525.
तो उसको मिली में कर देंगे, ठीक है?
35, yes sir. 35.25.
35.25 मिली एम्पियर. IBIC हो गया. Then VC, so VC equals to 12 minus IC 35.25 into 2.2. Okay, मिली किलो कैंसिल. So देखो कितना आ रहा है,
51.59.
इतना आया. इतना कहाँ पे गलत हो गया?
नहीं सर, 1 minute सर.
इतना नहीं आएगा.
सर 65.55.
5.5 volt. अच्छा चेक करो. So this is the procedure. Okay. Then VE is 0 here because emitter is grounded. So VC equals to same as VC. So this is the way the circuit will be solved. This is a 5-mark question. So you expect this type of question in the NSEM exam. So actually two questions, whatever we have discussed, 2 questions will get. One is from this fixed bias circuit, and another one is what is biasing, why biasing is needed, okay, or what are the parameter affecting the biasing. So you need to write everything, like what is biasing means definition, then this definition, then what are the parameters which is affecting. So you have to do this one as well as these things. Okay, why biasing is required. So biasing is required means to stabilize, these are the parameters which are affecting the Q point. To stabilize that, we need to nullify these effects. So after that also we will get some small question, short question like thermal runway. I have told today what is thermal runway. Okay, what is thermal runway? It is a short question. So these things you will get. Okay. Now, what is the advantage and disadvantage of this fixed bias? Advantage is very simple circuit. Less number of components are used. You can see one voltage source and 2 resistors are connected with transistor. So less number of components are used and simple circuit. Okay, but disadvantage that if you observe here, IC equals to this one beta IB. Here leakage current is not mentioned. If leakage current will be mentioned, then what I'll get? IC equals to beta IB plus beta plus 1 ICBO. Okay. Now if I find del IC by del ICO or ICBO, then what I'll get? Partial derivative with respect to ICBO. Can you tell me? In that condition, beta is constant, VB is constant. Beta and VBE constant. Tell me what I'll get? अरे पार्शियल डेरिवेटिव पढ़े हो कि नहीं? तुम तो कुछ भी रेस्पॉन्स नहीं कर रहे हो. इक्वेशन लिख दिया, पार्शियल डेरिवेटिव अगर निकल नहीं पाओगे तो कैसे होगा? क्या होगा? What is the answer? Beta constant, IB constant. With respect to ICBO, you have to find out. नहीं हो पाएगा. So this is constant, means derivative is 0. With respect to this one means I'll get beta plus 1. Okay. So beta plus 1 I'll get. So this is your stability factor S. Now if for this example what I have taken, beta is 75. So stability factor I'll get 76. That means one factor increase or 1 milli or even 1 microampere change in ICBO will affect 76 microampere increase in the IC. That means suppose one time increase in leakage current, that will affect 76 time in IC. So it is good or bad? Stability factor is more means it is good or less means it is good for amplifier. So you are understanding or not? I don't understand. I'm saying change in leakage current one time means IC is changing 76 times. Whether it is bad or good, we are not able to tell. If IC is changing 76 times of ICO, then just now I have what explained. Huh? Leakage current changing means IC is changing. So if IC is changing, I don't know what you are doing. So this IC changing means I am shifting or Q point is shifting upward. If shifting upward means the upper portion of the signal may clip. So whether it is good or bad?
Bad, sir.
So stability factor is more means it is good or less means it is good? This is bad. So if stability factor is less means it is good. So fixed bias circuit, what we have considered, that is actually bad. So generally we are avoiding this type of fixed bias circuit, this type of biasing circuit, because the stability factor is very high. So small change in temperature will change the beta, as well as the stability factor is increased. So fixed bias circuit is not used, but the demerit is this one, but merit is it is very simple circuit and less number of components are used. That's why it is included in your syllabus. Okay. So good type of biasing. There are a lot of biasing circuits are there. Emitter bias, collector bias, voltage divider bias circuits. So they are used. But for understanding purpose, it is included in your syllabus. Okay. So that completes your transistor. Till now your copies are not assigned. I don't understand. Means you are not replying. Let me see the question, your copies. Then only whether you are understanding or not, we'll see. Several times I have told you, every day once the class is over, you have to go through that. You are not doing that. It is evident from your response. Okay. If you think later on I will do everything, then nothing will be done. Later on you will think that this subject is difficult and you will skip. So don't leave the meeting. I will take the attendance. We'll leave. So next class we will start JFET, junction field effect transistor. So as we move further, slowly the syllabus will be increased and it will get tougher if you don't study regularly. I'm telling you every day, whatever I have taught you, you go through that, and if you have doubt, just ask me. You are not asking means you are not studying. You are not responding also in the class. What can we do? If you study, then doubt will come. If you not study, then just coming and going. Okay, so I have taken the attendance. You may leave now.
Thank you, sir.
At Jeffrey.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.